As you see up there, we're doing powers and roots of complex numbers. And what I'm going to do is basically give you a formula so that you can do high powers like to the 6th, 7th power. If you look at the first example, we have 2 plus 2 square root of 3i. And we have it to the 6th power. Now you could write 6 of those. Are you following what I'm talking about? You'd have 6 parentheses end to end, and then you'd have to FOIL 2 and then FOIL 2 and then FOIL 2 and then take the first 2 answers and FOIL that, and then take that answer and FOIL it with the last one. But if you need to do that, it's much easier to use the formula. Now, does anybody taking French? Anybody have French in here? Because I cannot pronounce this guy's name. Say it again. De Moivre. Thank you. De Moivre's theorem at the top, and it looks more complicated than it is, so I'm not even going to write the theorem. I'm just going to show you in this example how to do it here, because it's easier to show than it is to try to figure it out what the theorem is doing. But the first thing you already know how to do. You just took a quiz on it. I need everybody to change that to a polar, or to polar form. Go ahead and do that. Let's see if you remember how to change it to polar form. Okay, a little refreshing in your memory. What is polar form? Plus I sine theta. That's right. Then how do you find r? What do you use to find r? Square root of a squared plus b squared. How do you find theta? Tangent inverse of b over a. And also remember, if it's special triangle values, you need to do it in terms of a special triangle value. So first thing, r is going to equal 2 squared plus 2 square root of 3 squared. What do we get when we multiply 2 square root of 3, or excuse me, square 2 square root of 3? 12. Very good. Because what's 2 squared? It's 4. What's square root of 3 squared? 3. 4 times 3 is 12. So r is actually going to be 4. So now we have 4 for the r. Now since we're doing, this is going to be a special triangle because you're going to get square root of 3 over 1 when you simplify b over a, aren't you? Put b over a, you got 2 square root of 3. So we're going to do the tangent inverse of that. And then when you simplify that, doesn't it look familiar? It should. Isn't that 2 values from a special triangle? Square root of 3 is opposite to what? 60. So that's our reference angle. So we should see what quadrant we're in. Plus plus is first quadrant. So we can just stay positive and stay with 60 degrees, which is what in terms of pi? Pi over 3. Thank you. So now we have it. Now, is everybody okay with that? Just kind of a review of changing complex to polar. All right, I'm going to erase this now so I have some room. Or actually, I could just do this. So now we have, I want you to keep in mind what we're doing here. We're taking this to the 6th power. Right now it equals this in polar form. Let's see. Now, here's all you have to do. This is how simple it is, and so you don't have to look at the formula to do it. Since we're taking it to the 6th power, you just take 4 to the 6th, and then you take that power times each theta. If you look at the formula, you'll see that's what they do with the n, don't they? See the formula up there? They use n as the exponent. Isn't that what they did on the right side there with the n? Took r to the n, and then didn't they take n times theta? Right? Okay. So what are we going to have the cosine of now? I'm going to show it for the viewers that are watching this. We need to show it. We take 6 times pi over 3 would be that, right? Everybody with me? I'm just multiplying theta by 6 because the exponent is 6. This is not deep. This is the way you do every problem. Which means I have the same thing here. But if we simplify that, we also need to take 4 to the 6th. What do you get when you do that? 1096? No, 4096. Excuse me. Which you can do in a calculator real quick. So really now we have cosine of what? Then we have cosine of 2 pi. And anytime you see something like that, where do you go to get your sine and cosine values? Unit circle. And since 2 pi is right here, and we know our values are 1, 0, aren't they? Plug them in, distribute this, and you're done. So you'll have 4096. What's the cosine of 2 pi? 1. What's the cosine or sine of 2 pi? 0. Now if you want to write this, and I'll take it either way, in complex form, your final answer would be 4096 plus 0i, wouldn't it? Really nothing new here except a different formula which teaches you how to do powers, large powers on complex numbers without having to actually multiply it all out. And you can use your polar form to do that. Because this is what we started with, this is what it equals. Does that make sense? If I took this to the 6th power, you would get this if I multiplied it times itself 6 times. Okie dokie. Now there will be times, let's look at, try on your own there. Do you have a negative exponent? Is that a positive exponent? It's negative, isn't it? How many of you know what to do when you have a negative exponent? It's not going to affect this much, but normally, what do you do with the negative exponent? Yeah, reciprocal. You flip any fraction or any number that has a negative exponent to make the exponent positive. Now if it was to the negative 2 power, are you all listening? If it's to the negative 2 power, you flip it and then do what to it? Like if you had 1/2 to the negative 2. Flipping it makes it positive. I'm sorry, I didn't even flip it. Flipping it makes it positive, but then what are we going to do to it? Square it. So 1/2 to the negative 2, or exponent would equal 4 because you flip it and then square it. So I'm just showing you that because in this case, we're going to be flipping 1, and it doesn't really matter what you do when you flip 1. Are you following me? All right, let's see if you can try this one. See if you can try that one on your own. First thing you got to do is what? Put it in polar form. So we have the square root of 3 over 2 minus 1/2 I to the negative 5 power, or negative fifth. Now you're not doing anything with the negative fifth right now, you're just changing what's inside the parentheses to polar form. Now, even though that looks complicated when you're finding your R, it comes out to a nice number. I already told you what it was going to be. How many got 1 for R? Okay, here's how we get it. Are we getting this yet? How to square things with roots? So what's the first fraction here, square, going to be? The square root of 3 over 2 squared will be what? 3/4. Then when you square 1/2, what do you get? 1/4. And what's 3/4 plus 1/4? 1. So the square root of 1 is, so our R is 1. Now, when I put B over A, so we can do the tangent inverse. What's that going to equal? It's going to be 1. Yes. What do you do when you have a fraction divided by a fraction? Multiply by a reciprocal. So the 2's will cancel, leaving you 1 over square root of 3, won't it? Now we're going to do the tangent inverse of that. And again, this is a special triangle. But this time our reference angle is what? 30. But what quadrant are we in when we look at the original? 4th? Yeah, because we have to go positive right, negative down. Pi over 6 is the value for a 30-degree angle, but if you have pi over 6 in the 4th quadrant, if this is pi over 6 and we want this, what's going to be our value then? 11 pi over 6, isn't it? So in here we'll have cosine of 11 pi over 6 plus I sine 11 pi over 6, and all of this is raised to the, oh, sorry, negative, I'm thinking, what did I just do? Okay. Negative 5. Now, what did we do with the exponent on the last problem? So we can now take this to the negative 5th power. What do we do with R? 1 to the, well, let's do one step at a time. 1 to the negative 5th, right? Didn't we take it to the exponent power? Then what did we do with theta and the exponent? Didn't we multiply? So we got negative 5 times this, which would make it, okay. We won't go into that. Now, that's not very easy to figure out, is it? So can you think of an alternative way to write this 11 pi over 6 that's easier to work with? What could we do here? What's another way of writing 11 pi over 6? There you go. There you go. So why don't we use that up here? I'm showing the other part that sometimes you need to be a little creative. Use your math knowledge. Let's change this. I could figure it out this way, but some people would stop and say, I can't do this. All you do is make a mixed number and see how many times you're going around till you end up, and you're going to end up, at negative pi over 6, right? Or somewhere in there. All right, so let's change this to, what did I say we were going to do? Negative, right? So we'll change this to a negative. And then that will be easier to work with. Now when we take 5 times that, we're going to have what? Negative 5 pi over 6 times a negative, yes. So now we have a positive, don't we? Now that's a lot easier to work with. Now you know that's going to take you to a certain place where you can figure out your answers. Go ahead and finish this for me. See if you can find the final answer for me. As I said, this negative doesn't really affect 1 much, does it? The negative exponent. 1 to any power is what? 1. But that's why I showed you the other cases. Sometimes you have to flip them, but if you flip 1, isn't it still 1? So it doesn't affect it that much at all, actually. So what is our value for cosine? This is going to be 1, which we don't even have to write, really. 1 times anything is the same thing. That's a cosine of 30 degrees, isn't it? In the second quadrant. What is cosine in the second quadrant? Negative, and go ahead. Square root of 3 over 2. And then sine of 30 is going to be positive. Yeah, I got my I here. Now, don't forget your I. What are we going to have? And if you distribute the 1, you're still going to get the same thing, aren't you? How many of you feel like you at least understand the flow of the problem, even though it may have been a few hang-ups there, but you understand the flow, right? Okay. If you got there before I did, give yourself 2 bonus points. Now turn the page over. I think we're ready to turn it over, yes. The next problem is not hard. It's the same idea. It's just setting it up is a little different. This time we're going to do a root. It says find the principal cube root of 8i. Principal means just find, there's actually 3 cube roots of 8i. 3 possible answers. But we only use the principal answer when we're doing math in a problem, unless they specify to ask or find all 3. The problem we're not going to do at the bottom is how you find all 3, but we're not going to do that. You have to use that formula at the bottom to do that. We're just going to find the principal one, which means I need to do this. Does anybody remember how you rewrite that with an exponent? How do you change from radical to exponential form? Very good. Yes, very good. This actually, you put the power over the root, but this is to the first power here, isn't it? It's not, there's no other power. So it's actually 8i to the 1/3. How many remember that cube root is 1/3, fourth root is 1/4, square root is 1/2 as a power? Now why am I changing this to a power? What have we been doing? What's our formula use that we've been doing? An exponent. That's why we got to do that. But to do this, we need to write it in a plus bi form, like this, because don't we need the a and b? Does that make sense? For us to find everything we need the a plus bi form. These are easy. Now, can anybody just intuitively tell me what we're going to use? When you see a 0 in here, where does that put you to find your sine and cosine? On an axis. Because where would you be if you graphed at 0, 8? Where is 0, 8? Isn't that pi over 2? What are the ordered pair of values there for sine and cosine? Isn't that 0, 1? So see what I'm talking about? If you see where you graph this, it tells you. It's on an axis. It's on the unit circle. So we got our theta right away, don't we? All we need now is our r. How do we find that? Square root of a squared plus b squared. But aren't you just squaring the 8? 8 squared is 64, and then the square root of that again would be 8, wouldn't it? So we have 8 cosine pi over 2 plus I sine pi over 2, and all of that raised to the 1/3, don't we? So all we did was take this and rewrite it in polar form. So we can use the formula that you used on the first two examples. But this time we take 8 to the 1/3, which means we really want the cube root of 8, don't we? How many know what I'm doing here? I'm just moving it back to a cube root so we can figure it out. And then, what do we do with the theta? Multiply by 1/3. So we'd have 1/3 times pi over 2, which is pi over 6. You multiply straight across, don't you? So now we have cosine pi over 6 plus I sine pi over 6, and we're ready to figure it out now. When we get done, you found the cube root, the principal cube root of 8i. You took the cube root of it without using a calculator. So, what's the cube root of 8? 2, because 2 times 2 times 2 gives you 8. What's the cosine of pi over 6? We're in the first quadrant, aren't we? Square root of 3 over 2. Am I going too fast? Are we going too fast here? Do I need to draw it? Just to be safe? Just to be safe, we'll write this up in case there are people watching this that don't know what we're doing. Cosine, excuse me, pi over 6 is the same as a 30, and it's adjacent over hypotenuse, isn't it? That's where we got that. So that means sine is opposite over hypotenuse, isn't it? So now we have plus 1/2 I. Multiply, distribute your 2, and we're done. So 2 times this would give us what? Square root of 3 plus I. Did anybody get there before me? Give yourself 2 bonus points. And you know how to do these problems. So your assignments, 605 up there on the board, 12 through 20, 22, 23, and 25.